let's continue with our methodology 4, whereby we need to deal with supermesh condition. What is actually supermesh condition? Supermesh can be defined when a current source exists in between two meshes. Okay, so for example, if you have this circuit, right, this is your current, a current source, right, exists in between two different meshes. For example, like this. So you have two different, this is M1 and this is your M2. So how to solve if we have this sort of configuration? How to solve? Right? We need to firstly prepare supermesh equation, and as well as number 2, our support equation. I will explain later. Right? Let's start with this example. If, for example, we are having this circuit, so as you can see, we have voltage source over here, but we have current source over here. And this current source exists in between mesh number 1 as well as mesh number 2. Then we need to solve this using supermesh analysis, which requires supermesh equation as well as support equation. Through this example, we are going to learn how to write supermesh and support equation. Okay, let's say we redraw this circuit. Okay, as you can see here, we have this is VB1, R1, R2, IB, R3 as well as VB2. Okay, this is my first mesh, I1. This is my second mesh, which is I2. But you must remember, since IB is being shared in between mesh number 1 and mesh number 2, we need another super mesh that will cover the whole current flowing throughout this circuit. That's why this is the situation. We are creating now supermesh condition over here. Okay, now what is supermesh equation? So supermesh equation is the whole equation throughout this direction. Okay, so we can see we have one, for example, one terms, second term, third, as well as fourth. That's why our supermesh equation begin, for example, from number 1, I1 R1 plus here, what are the current flowing? Only I2, right? That's why I2 R3 minus VB2, and then it flowing through here, and then minus VB1. Let me rephrase, let me re-explain. Okay, supermesh equation is your bigger looping over here. And for example, we start over here, right? So for R1 only I1 flowing, right? R3 only I2. That's why I1 R1 plus I2 R3 minus VB2 minus VB1. So this is our first equation. Right now, what is our support equation? You must remember, support equation is actually happen in between this junction where your current source being shared in between these two. That's why as I'm having here, this is actually your IB, right? The same thing like this. But here you have, you must remember, this is your I1 originally, and this is your I2. That's why I'm having I1 in this way, while I2 in this way. Then we can write using KCL, right? I1, current entering, your I1 entering this node equal to current leaving. Right, so your current leaving is IB as well as I2. Or you can also rewrite I1 minus I2 equal to IB.